Good afternoon, everyone. How are you? Please put your name if you're in the chat. Please put your name if you're in the chat. Welcome, everybody. Please put your name if you're live with me. Please put your name in the chat so I see where everyone who is present. Seth, are you present? Antonisha. Oh yes, Antonisha, I see you there. Put your name in the chat if you're present with me right now. Welcome to our lesson. We're about to start. I'll start in like a minute, okay? Put your name in the chat if you're present now. Please put your name in the chat so I can see everybody who is present with me right now. Okay? Please put your name in the chat if you're present. Hi, Nahum. How are you? Okay, I see Antonisha. I see you now. Great. Please put your name if you haven't. Put your name in the chat. We're about to get started. Put your name in the chat so I see everybody who is present. Hi, Rumbi. How are you? I see you there. Anyone else? Where are the others? Gamu, are you in the chat? Lily, Loveness, Akiana, Michelle, Uratile Inzwi. Anyone else who is in the chat, please put your name. Put your name if you're live with us so I can see. Okay, so because of time, I'm forced to get started. If you have joined, please just put your name in the chat so that I'll see. I want to see everybody who is present. We're continuing with our maths. So let me put the IGCSE maths. We always need to know, whenever we do something, we need to know where it is from so that we can track our progress, right? We want to be able to track our progress and see how far we are every single time in every single lesson. We want to know what we know and we want to know what we don't know yet so that we can improve on that and make sure we are perfect, okay? We are not leaving any stone unturned. By the time we go into the exam, we should be knowing every single corner, every single page, every single concept, okay? We're not going to be surprised by questions. So let's we know that, I always like to show you, we know that we have 9 topics in IGCSE maths, right? We know that we have 9 topics from start to finish, and the order can be different. It's not important, but the first one is number. The second one is, sometimes there's algebra and graphs. Sometimes they can call it, here I'm going to call it linear algebra. This in the syllabus is written as topic number 3, and the syllabus writes it as coordinate geometry, okay? But don't worry, you can trust these words that I'm giving you, okay? The things that I'm giving you, it's important. I'll explain later, not now. Algebra and graphs becomes the third one. Algebra and graphs becomes the third one. Then the fourth one is going to be mensuration. So, no, not mensuration, but geometry, rather. The fourth one is geometry. Then the fifth one is going to be vectors and transformations. Okay, which can swap with trig. Sometimes trig, we write it as number 5, then we write vectors and transformations as number 6. That doesn't matter. But the 6th one will be trigonometry. Then we have the 7th one being mensuration. That is the one which we are looking at today. We are continuing with this one. Then we have the 8th one being probability. Then we have the 9th topic of our IG, so probability. Then we have the 9th topic being statistics. If we know this, we are done with Cambridge IGCSE mathematics. So we must know all of them, and we must be able to answer past paper questions. So that whole step, I tried to have us do both at the same time. So at the same time, we will be doing the learning, the concepts, and at the same time we'll be doing past papers because we are writing this year, so we don't really have time to just be doing easy questions and then later on in September we start doing past paper questions. That will help. That will just pile a lot of pressure on us, unnecessary pressure, which we're not going to do, okay? So what we are going to do is to make sure we are moving well with every single thing. Hey, that's what we're going to do. Anyway, So right now, the moment I teach you, we're going to past paper questions and we are going to solve, right? So what we are doing is chapter 7, which is mensuration. Chapter 7, which is mensuration. So this is what we are looking at, and we're going to be answering past paper questions to do with this concept. So can you put chapter 7, mensuration, okay? All right, so now let's do. Last time in the last lesson, we were talking about something which is very important, and we're continuing from there. Mensuration is the topic which asks you about area, volume, total surface area, those things. So when you see a question which has the word perimeter, or the word total surface area, or the word volume, anytime you see those words, you are in mensuration. That is the topic. Mensuration is that topic, okay, with those things. So let me put them. So what we would be saying is we have. Last time we were talking about a very important thing that's which always comes. We started with that, and then we will add to other shapes, and that was a sector. So we make sure everybody remembers this. We talked about a sector, and we said I want to make sure you are all good. We do a few more questions, and then we do other shapes as well. So we said a sector is a piece of pizza. It's anything that is cut from a circle. When you cut a circle, you get a piece of a circle, right? That's a sector. It looks like a piece of pizza, like a slice of pizza, okay? It looks like a slice or 2 slices of pizza or whatever, okay? 3 slices or whatever. It can be big, it can be small, but when you cut a piece of a circle, you get a sector. It's like this. Now, there are things that you have to know about sector. This is the first thing we're looking at. Then we'll talk about some other shapes. We'll talk about the shapes, finding areas, finding volumes. We'll talk about it, okay? Now, this is chapter 7. This is mensuration, chapter 7. Somebody's asking me. Right, so this is chapter 7, mensuration, where you talk about volume, you talk about area. Each chapter has its own thing. So you don't mix. When you do a past paper, the strength, if you want to be acing everything, when you get to a question in a paper, in any subject, whether it's maths, whether it's physics, whether it's bio, you have to thoroughly understand your syllabus in such a way that when you look at the question, you should know what chapter it is. You don't panic. You're like, oh, I know this. This is mensuration. I'm looking at the sector. This is what we do for this one. This is what you do for this one. You will be knowing what you do for each of those things, okay? There's no way of being confused if you approach it like that. So we said when you see a sector, a piece of pizza, you are in this chapter. Now, what do you talk about when you talk about a sector? Right, here are the things. So I want you to know that a sector has these 2 sides being equal all the time. You know, sometimes they can give you a sector like this. Let me show you. They can give you a sector like this, or even like this. Let me make it weird. Let me make it weird. Like this. A sector like this. It's still a sector, okay? It's a piece of a circle. So this is still a sector. Are you telling me? Yes, I'm telling you. And what I want you to know about a sector is that this side here is a radius. So we'll call it R, okay? This is a radius, so this is R. And this other one here is a radius again. This is another radius again, so we'll call it R. In other words, if you are given that this is 15, automatically you also know that this will be 15, because both of them are radii. They're the same, okay? They'll be the same length. So you should know that they're the same. It's a radius and a radius, so they're exactly the same length. Just like here, this will be a radius and a radius. You must know that, okay? We are not negotiating. We are telling you. We don't care where they're facing. They are radii, okay? They are radii. And then this curved part of your arc, or of your sector, is called an arc. So this would be called an arc, the curved part of your sector. Okay, this one. Whether they're going to call it major or what, we don't care. But this is going to be the arc. They can call it the major arc or the minor arc. You know, this is going to be an arc. And what you must know is that the arc is called S. The arc is called S. Okay? The arc is called S. Yes, I'll be doing revision every single year. Sure. I'll be doing revision every single year, okay? Don't worry about it. Every day, every single year. So here's the thing. What I'm saying is, this is going to be the arc. Then we have the sector being inside. Then we have a radius and the radius. So this is radius. You must know this. The piece of pizza, you must know the lengths, these three things. Okay, so there's a radius and an arc. Then you are done with the sector. So you must first know the sides. Radius, radius, arc. Radius, radius, arc. So if they now come and ask you, what is perimeter? They now ask you, what is the perimeter of a sector? Remember, perimeter means the distance right round it. So you want to know the distance, the total distance if you go right round this whole piece of pizza. So how will you go around it? You first take this radius, then you take this other radius, then you take the arc. Then you have the whole distance. So it's going to be 2 radii plus the arc S. So you'd be having the perimeter. For you to find, that's the formula number 1 that you must know. Formula number 1 that you must know is the perimeter. Formula number 1 you must know is the perimeter. Radii, radius, radius, and arc. So it'll be 2 radii plus the arc. There we go. Okay, that arc length is. Okay, then we go to the second thing now. And the second thing is, how do we get the area? How do we get the area? Okay, how do we, before we do area, let's see how do we get the arc length S. The arc length, because that is the length of the, when you see the word arc, it's not talking about the inside. It's talking about this part, this S, that's the arc, this curved thing outside. That's the arc, and we want to find its length. Oh, hi Sheena, I see you. Hi Gamu. Welcome. Who else is there? Please put your name so I can know if everybody's there. Where's Uratele? Where's all these people? Put your name in the chat if you're here. Well done, Gamu. I see you. So this is arc length, and arc length is S, and it will be equal to R theta. So the next formula we have to know is that S is, oh, hi Shuaib. S is equal to R theta. So this is going to be what you should know. The arc length S. So when you want to find perimeter, the first thing, they won't tell you to find the arc length first. They won't make it that easy. What they'll just say, they'll say, find perimeter. But I want you to know that if you want to find perimeter, you should first find S if you don't have it. Because most of the time, oh, in VIC, Akiana, well done. And I'll see you. So you make sure you have S first. If you don't have S, then what are you going to find? You're not going to find the perimeter. They won't tell you, but I've told you. Now you know, first find that S, because we want the whole distance. So we need S first, and then we are going to be able to find the perimeter. Now the last thing about this small piece of B that we talked about last time is the area. If your area is equal to half R squared theta, okay? We'll be able to find the area if we do this. Area will be equal to half R squared theta. Area of the arc. We can find the area of this arc. The area which is all the distance inside it, all the thing inside it. And what is theta, by the way? Because you can ask me what is theta. Theta is this angle here. It's theta. Okay, theta is this angle here. So you'd find area is equal to half R squared theta. Okay, Phoebe, no problem. I see you there, Phoebe, fine. So this is going to be the area. Area is half R squared theta. So perimeter, arc length, area. So the moment you see this shape, don't even panic. The last thing you're going to do is panic. The moment you see this shape, put these 3 formulas. Put these 3 formulas and they are going to work, okay? Once you put these 3 formulas, they are going to work. They are going to work. Put these 3. Now, there's one more thing I need you to know. NB. Okay, so we are dealing with a piece of pizza. Remember, we are going step by step. Don't rush. We will do the other things. I always say this. Don't try to know the whole thing. We are going step by step. Okay? We are going step by step. We are doing arcs and we are doing the other things. The other things I don't have to even tell you because I'm going to show you the cheat code for this one. I'm going to show you the cheat code because for the papers you are now getting, all these things will be given. All these other things will be given, okay? When you go to the front of your paper, you're going to see all the formulas you're going to need for this chapter. So we're going to box it up just now, okay? So the first formula, perimeter. Okay, I'll explain it just now. One more thing I want you to know is that you should make sure theta, okay, which is theta, is in radians. Make sure that your theta is in radians. You should always make sure that if you have it in degrees, don't use the degrees, you'll be in trouble. Use it in rad. How you're going to do it is, this is how you're going to do it. You are going to say that theta in degrees, you divide it by 180 degrees, then you multiply by pi, okay? Then you'd have radians, so you'd multiply by pi. So you're going to divide it by 180, you multiply it by pi. Then you're going to have your theta in rad. Always do that, okay? This is what you're going to do to get theta in rad. You're going to divide it by 180 degrees, then multiply by pi. Then now you can use it. So what are you saying? Tell me everything you have said. The first thing I've said is that sector is a piece of pizza. It always comes. Okay, I'm going to go and show you in questions. Yes, let me explain it now, Shuaib. So you have a piece of pizza right now. A piece of pizza, slice of pizza. There we go. Okay. So what you must know is that this slice of pizza has 3 sides that you must know. You have to know the 3 sides that this slice of pizza has. One is this one, called radius. The other one is this one, called radius. The other one is the curved one. This one, we call it the arc, which I'm putting in green. I'm highlighting in green. It's called the arc. Okay, it's the arc. S. So you must find, if they say to you, find perimeter, they want the distance right round. You go right round it. So you're going to say radius here, then you go another radius, then you go arc. You would have gone right round the whole thing. You would have gone the length of the whole thing. Let's say you are walking right round the whole thing. You walk radius, then you have another radius, this other side, then you are going to have the arc S. So if we are finding perimeter, we want the total distance right round. So it's going to be radius plus the arc S. This will give us perimeter of this thing. This will give us the perimeter. Now R plus R, you get 2R. So it will be 2 radii plus S. This is going to be the formula we'll use for perimeter. So for perimeter, we'll use the formula 2R plus S. Never forget that. Never ever forget that. So that's going to be the formula number 1. You should know that perimeter is 2R plus S. But to find S, you're going to need to calculate it. Most of the times they'll give you radius, or even if they ask you to find the radius, don't worry. You use this second formula. S is equal to R theta. So if I want S and I don't have it, I'll just have this formula. S is R theta. So I'm going to multiply. But I'm going to make sure that this is in radians. So if I'm doing in steps, the very first thing you should always do is convert all angles to rad. Then you find S. Then you can find perimeter. So if you get an angle in rad, convert it. If you get an angle in degrees, convert it to radians using this. Divide by 180, then multiply by pi rad. You would have converted it to rad. When you convert it to rad, you will now come in here and get S. When you have found the S, you will now come and you can find perimeter now, because you know S. Come on now, don't let me down. Then if they ask for area, first convert theta to radians. When you convert theta to radians, then you come and put it in this formula. Half R squared theta. You will find the area of the arc. You will find its area and you'll be fine. You'll be fine. You hear me? So now let's go to just do some questions. And there are other things I want to show you. So let's go to a paper for the other things to do with this topic called mensuration, okay? So let's talk about this topic. Let's go to a paper. Let's see if it came in 2021. Let's start with 2025. You know, I don't like doing 2025. I want it to be done by you guys, but I'll just do one. I want you people to do 2025. Boys and girls. I want to leave it for you after I show you using the older papers. Okay? Yeah, I'll do 2024. Let me see if there is. PYQs. Can Can you get my email and send me things? Or I'll do it. You know what I can do? If I do certain questions, you know they'll come again for PYQs. Just look at the type of question, it will come again for a PYQ. Okay, so look here. There we go. There we have a piece of pizza. You see, I just went to a general paper and we have found the questions. It always comes. It comes a lot of times. So once you see this, you do not panic. This is just a piece of pizza. This is just a piece of pizza. So what is going on with this piece of pizza? We know that this is R. Obviously, this will be R as well, centimeters. And this is going to be S, okay? This is going to be S. So anyway, they're saying the diagram shows sector with the center chord. The shaded segment has area 30, whatever. They're now talking about the shaded segment. So, one thing I don't like about this question is that I don't want to use things to do with trig or anything. I wanted to use things just to do with the sector. I'm not going to I don't want to mix things, okay? So, you know, if we talk about this, let me explain something, right? And then I'm coming back. Let me explain something to you people so you understand. There's this topic. This is mensuration that we are doing right now. What I want you to know is that, okay, this is 2024, so it won't show you. Let me go to a 2025 paper. Look at what happens in 2025. For paper 2 and for paper 4, you are going to be given formulas. Yes, let me give you Instagram. Yeah, you can DM me. You can DM me Instagram. You can DM me on Instagram. Let me show you. Let me share my Instagram handle. Okay. The admin will put it in the chat. I'll continue speaking. The admin will put the Instagram handle in the chat. Please put my Instagram handle in the chat. Yeah. Yep. I'll put it. Here's what I want you to do. Let me open the 2025 paper. Antonisha, here's the 2025 paper. This topic, so what you're going to do, Antonisha, you go into an exam. Gamu, look at this, and Rumbi and everybody. Inzi, you see these formulas that they're going to say list of formulas. They are all from chapter 7. All of them. So chapter 7, we are sorted because the formulas will be given to us, okay? So if you scroll down, Gamu, all the way until you get to here to the quadratic equation, all the way until you get to the quadratic equation, this is going to be formulas for chapter 7. So anything which I'll need in chapter 7, I should come and put it. If you want, you say, Mr. Here is my Instagram handle, Mr. Clarify, Mr. then underscore, okay? Mr. underscore clarify, then underscore, then videos. This is my Instagram handle. Okay, so what I was saying is all these formulas are for chapter 7. Now what they will do is if they give you a question from here, they will join up shapes, shade regions, do everything to try and get you not to see what shape they want. But you always number the shapes. So you see them piece by piece. You don't see it as one. Like if I'm going to scroll down in here, 9 times out of 10, let's find that chapter 7 question, okay? We'll scroll down, looking for the chapter 7 question, eh? This is vectors. Don't worry about vectors. Vectors. Okay. Let me open 2025, October, November. This one. Right. Let's look for a question so that I show you what they'll do. I don't want triangles right now. I just want things to do with mensuration itself. So let me see. What paper did I just open? I didn't see. I don't know if I opened this one. I just opened paper 4.1. Okay. So this is going to be paper 4.3. Look at what they do. I want to show you. Which paper was it? You can see the formulas you'll be given. Don't worry about it. 0580 question paper 4.2. Wait, let me find it. I can't see it. March question paper 4.2. So let me see. Okay, look at here. This is an example, but here they just cut one piece. They can make it even bigger. So look at what they've done here. They've cut, it was a circle, they cut it off like this, right? And they've cut it. This is not a piece of pizza. You don't have radius and radius here. This is a segment. It's called a segment. So what they've done, they've made a tunnel and whatever. They'll ask you to find the volumes of these things. What they are just trying to have you not see, they are trying to have you not recognize the shapes they are giving you, okay? Oh, that is all this game will be about. So your success and my success and our success is we should know what to do when they join shapes. Because when they join shapes, you should see, oh, there's a cone below, there's a semicircle at the top, there's this, there's this. You should be able to see all that. And I want you to be able to know when they cut off shapes. When they cut off shapes, how do you handle with it? Okay, when they cut a piece of a shape, how do you do it? So if you go back to this question that I'm doing with you for a sec, this is the same thing they do for the whole chapter 7. So chapter 7, we are ready for it. I'll in the next lesson, I'll do a bunch of questions tomorrow. Okay, in our, tomorrow we do that long revision thing, right? So I'm going to put several chapter 7 questions and show you, and I'll be giving you the formulas because nowadays you get the formulas. So. And then I'll solve the same things, okay? In here, we are doing this one. In here, we are doing this where they have a sector. So can you open? But this is still chapter 7. So we are expecting them to do the same things, okay? The same things they do for chapter 7, which is your thing has been cut, okay? They're trying to have you not recognize what is going on, right? So your thing has been cut the thing has been cut, shaded rather. Let's not say cut. But the only one part of it is shaded. And they've told you the area of the shaded segment. So the difference between an arc and a segment is, in a segment you'll be having something like this, right? Then the center is here. Then you just come and put a chord. A line which doesn't pass through the center. So it does not create you can't come and put half and say this will be a radius, this will be that's a lie. This thing is not passing through. So it's like in a segment, if I just come and put a line like this, then I shade it like this. This is what we call a segment. This is what we call a segment. And here, that is what they've come and given you, okay? They've come and given you what? They are giving you a shaded, they said, the diagram shows a sector of a circle with center O and chord AB. Of course, they don't tell us. The area of the segment is 30 cubic centimeters. Now, one more thing that I want people to know is when you're doing, because the next question they'll ask you for, this is the very last question, by the way. One thing I want you to know is that any statement that is said in these papers, you have to convert it to a formula. Any statement that is said, you have to convert it to a formula, okay? So what do we know here? Let me put it. First thing is, I'm going to convert these degrees. We're going to find area of the sector, then we're going to subtract and we'll talk about it. So let's say, how would I want to find area of this sector? Because I've been given a piece of pizza. I would say the first thing, convert theta to radians. So I'm going to say theta in rad is going to be 50 over 180 degrees, 50 degrees over 180 times pi rad. This is going to give me theta, right? And what am I going to get if I get theta here? I'm going to get whatever, tell me the answer. 50 over 180 times pi rad, what are we going to get here? 50 divided by 180. Second function, I've converted. This is equal to 5 over 18 pi rad. Okay, so you can say 5 pi over 18 radians. This is going to be our angle, right? Now, what do we know? We know that if I want to get the area, if I want to get the area of this segment, there is no formula in the whole world that has told me how to get area of a segment. But what I know is that if I want to get area of a segment, I'm going to say, this is the game. It's a game. The game is this. You get an area of a weird shape, which is a segment. Now, the only way to get area of a segment is you get area of the shapes that you know and you remove them. So the sector is the whole thing, right? Sector would be the whole thing, including the segment. So if I get area of the sector, that is the first area of the sector. Then if I remove from it, I subtract from it, area of the triangle here, which I didn't want to do because there's area of a triangle. If I remove area of the triangle here, then I'm going to have the area of the shaded thing. So they will try as much as they... You know, when I do more questions with you people tomorrow, you get the whole concept. For this one, it was a bad question, not a fun question, but it's still okay. You were asked to say, show that R is this. But what we know is that when they say show that R, they're just trying to say calculate R. Now, how are you going to calculate R? Is there a way of calculating R? No, you use things that you know about this topic. One thing we know is that we know area of a sector. Area of a sector is what? Half r squared theta. And we know area of a triangle when we have theta. Okay? What is going to be the area of a triangle when you have theta? Let me show you like this. If you have a triangle which is just like this and you have this angle, okay? You have a triangle like this. You are going to need to know this side and this side. We call them the ABs. Then you need to know the angle which is sitting between them. So you will be given this side and this side, then the angle which sits between them. So to get area, you now say area will be equal to half AB, then you say sine of the angle that sits between them, which is theta. That's how you get area of a triangle like this. So if you have here, this is my A is R, my B is R again, and my theta is 50 degrees. Can I keep it as degrees? Yes, you can, because you are saying sine, so you can keep it. So you will now say area of segment is going to be equal to area of the arc, which is half r squared theta minus half AB sine theta, which is the area of triangle. Area of triangle, you subtract it from the area of the whole sector, then you have the segment. With experience, you get better, guys. First of all, let me ask, can you guys understand what I'm doing so far? Guys, can you understand what I'm doing so far? Area of a sector, we put it on the three areas. We said area of a sector was half r squared theta. And we said perimeter of a sector. For sector, we know all the things. Perimeter, we said it was 2r plus s. And we say we had the third and final formula, s was equal to r theta, right? These are the things we had. So let me say, this for the sector. Okay, Akiana, let me explain. So these are the things we have. For the sector, we know these things. For the sector, we know these things, right? For the triangle, we've just learned right now. We've just learned that for a triangle, there are two ways of getting area. One is if it's a right-angled triangle, which we don't have right now, okay? A right-angled triangle is a special triangle. It's very rare. That's when you have base and height. And you'd say, oh, area is equal to base times height over 2. This one is very rare at IG, okay? What you have is you get something which is not a right-angled triangle like this. And they'll say, please find its area. But what they'll do is they'll give you theta, then they'll give you A, they'll give you B. So they will give you two sides and an angle which sits between them. You would just say area is equal to half A, B, sine theta. Sometimes they say half A, B, sine C, yeah, what. It's this one, it's just this formula. So you people have enough. This is all you need to know. Have you seen? So we have these things. Do we know anything about a segment? No. Okay, don't let it fool you where they just go somewhere in a circle and they put a line. We don't work like that. If you go somewhere in a circle which we don't know and you put a line and you ask us to find area, the only way we are going to find that area is by removing. We can't find it directly. It's impossible. So here they mentioned area of a segment. The shaded area. Here's this. Of course, they're talking about area of the segment. Now, you need to put out the formula for area of the segment because you've been given that area. So you need to put its formula, right? So that you can make it equal. So you've been told that this is 30 centimeters squared. So what we are going to need to do is this is for area of this. So what we're going to need to do is put that formula for that area. We calculate, then we make it equal to 30. We'll get an answer. So because that's what we've been told. We've been told area of this shaded thing. To get area of this shaded thing, we'll get area of the whole sector. Then we are going to remove area of the triangle. Then we'll remain with area of the segment, this one. So you say 1 minus 2, you'll get this segment. That's what we're going to do. Do we know for the sector? Yes, we know. How do we get area for the sector? Because they want area of the segment. So how do you get area of the sector? It's a formula. It's one of the three formulas we know about a sector. It's half r squared theta. But when we are doing for sector, we make sure our theta is in rad. Then what about for this triangle? It will be half AB sine theta or sine C or sine theta. So can we use these two? Yes. We subtract them? Yes. We'll get area of the shaded thing, this segment. Yeah, we'll get it. Are you sure, sir? I'm 100% sure. Should we try it? Yes, let's try it. So this is going to be equal to, what is the half r squared? So we've put half r squared theta for the whole sector. Minus, we'll do minus the triangle. So what is it? It's going to be half r squared. We don't know the r, by the way. Theta is 5 pi over 18. Okay? Should be in rad, right? Then we say minus half. What is the A? A is r. What is B? B is r again. Okay, we are looking at the triangle, right? We are now looking at the triangle. Let me change the screen. We are looking at the triangle like this. So the A is this r. The B is this r. So we'd say half AB, then we say sine. What is theta? The C? It's 50 degrees. Okay? And here, what would this be equal to? It will be equal to the area of the segment. The segment, what is the area of the segment? It's written here, 30. So it will be equal to 30. It will be equal to 30. That's the area of the segment. Because we've been told that the area is 30. So area of segment, we've been told that it's 30. So instead of writing area of segment, we can now write 30. Okay? 30 is equal to now this. Then we can find R. And you get 4 marks. 4 marks in IG is a lot. So you are now going to solve. So 30 will be equal to here. Let's see what we'll get here. So you'd have here half. Let me just say this. If somebody is saying, we have half r squared by 5 pi over 18. Minus here we have another half r squared by sine 50. So what we can do, I'm going to remove sine 50, right? I'm going to remove r squared, I'll factor it out. So it's going to be here half of 5 pi over 18 minus half of sine 50. Because r squared is on both, so I'll factor it out. I'll bring r squared out. Then I'll take this thing. What is half of this? Huh? It'll be 18 times 2 is like 9 times 4. That's 36. So it'll be 30 is equal to r squared multiplying 5 pi over 36 minus half of sine 50. You can just say it'll be sine 50 over 2. Okay? Because 2 just goes in the denominator. So what are we going to now get? What do we now get? We will take this whole thing as it is, this whole thing, to the other side to divide. So you're going to end up having, let me move these things. This is now just, we are now just simplifying, okay? So be careful when you simplify, because you've done all the work. You've done the hard work now. Hey, you've done the hard work. You cannot lose a mark on simplifying. Class, come on now. Don't let me down. Let me reduce the size. Write small things, okay, so that they can fit when you write your exams. So now what will we have? We are going to finish it. It'll be now what? We'll now say 30 divided by this whole thing. 5 pi over 36 minus sine 50 degrees over 2. Is equal to r squared. Okay, because we'll take this to the other side, it will divide. It was multiplying r squared. When it goes to the other side, it will divide. Then you take this squared, okay, this squared on r to the other side, it becomes square root. Square root of 30 all over, you open bracket, say 5 pi over 36 minus sine 50 degrees over 2. If we make a mistake here, woo, that's going to be deadly. There's going to be r. So now let's punch. Let's punch together. If you have a calculator which cannot punch this together, what I would rather say, I would say open bracket 5 pi over 36. Make sure your calculator is in degree mode, by the way, because the one you're going to punch is actually degrees. So make sure your calculator, because you have that sine 50 degrees, so make sure your calculator is in degree mode. Okay? So now, let me try to put mine. It was in radians. I'm trying to put DEG. Okay, now what I'm going to punch is, I'll say open bracket 5 pi over 36, close bracket, minus open bracket sine 50 divided by 2, close bracket, is equal to, I get an answer, okay? 5 pi over 36 minus sine 50 over 2. I got an answer, right? Then I'm going to say 30 divided by that answer. Okay? I'll say 30 divided by alpha equals, which means 30 divided by the answer. Then I say it is equal to, I got a big answer. Then I'll say square root of that. I'll get 46.7, blah, 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 blah. Then divided by, let me see here. Here it was 5 pi Let me find the final answer. We should get 23.7. Give me a second. You divide by 2. So it's going to be 5 pi, open 5 pi, 36, close. Say minus, open bracket, sine 50 divided by 2, close. Is equal to. Then I'll say 30 divided by that. I get an answer. Then I'm going to say square root of that. Okay, yes, I get 23.7. So this became 23.7, and this is centimeters, which is just r. Okay, so punch carefully. 5 pi divided by 36. You open bracket, you say open bracket 5 pi divided by 36. Then you say minus open bracket sine 50 divided by 2. You get an answer. Then what you're going to say, you say 30 divided by that answer. You get an answer. Then you say square root of that, you get 23.7. So this is going to be the final solution. Everything here is correct. Well done. I found my R. Now they want perimeter of what? Of the shaded segment. Perimeter of the shaded segment, you need to first know you find S. Then you're going to find this length here, which is a bit of trick to find this length. I don't want to do it. It's nothing to do with the sector. But you first find S, okay? You should find S. So first you'd say perimeter of the shaded segment. You want S, which is going to be R theta, which is going to be 23.7 times the theta in rad. You found your theta in rad to be 5 pi over 18. So times 5 pi over 18. So what would you get? You'd say 23.7 times 5 pi. You get an answer. You say divided by 18. You get 20.7. So this is going to be 20.7 centimeters, the S. Then you now need to find this length here using trig, okay? Using trig, you can find this length using the cosine rule. You can find it. I'm not going to go there, but once you find this length, then you can be able to add it to S and you'll find your things. They'll give you 4 marks. We are not looking at it right now. That's what I'm not doing. I want us to look at the sector. We are focusing on the piece of pizza. Is there anyone with a question? Can you all hear me? Can you all hear me? And have you seen what we have done? Guys, can you all hear me? Akiana, Antonisha, Inzwi, Gamu, Seth. Have you all seen what we have done? Guys, can you all hear me? Okay. Well done, Antonish. The things we are really learning, learning is here, the sector. Doing things to do with the sector, this piece of pizza. So there we learned how to find segment, but we really wanted sector. Segment, we don't have a formula. Don't ever come to me and say we have a formula for segment. Did you see anyone give you that? You have to take the pieces that you know, you subtract them, then you get segment, okay? So that is what we did there. Okay, that is what we did there. Good. Okay, I see Rumbi there and Antonisha. Where are the others? Akiana? Is it better now, Akiana? Let's look for another piece of pizza. Then I think I'll be happy with what you know. I just want to give you questions on the piece of pizza and I want to see you people solve them. Let's just look around the papers and see if we can find it in a paper 2 or whatever. I want to see 2024 paper 2 if they gave this type of question. Does it come in a paper 2? We never know. But definitely in paper 4. Oh, okay. So paper 2 is where you find most mensuration questions that I was talking about. Here are pieces, they can cut it and they find this and find that. You know what? If they want anything to do with the shape itself, it's so easy because the formulas are in front here for mensuration. So that's what we'll be doing tomorrow. It's so easy because you didn't have them back then, but for now, 2025 going forward, the formulas are going to be in front. So we will have formulas. So I'm going to open for any year, right? We'll do the questions, but the formulas will be in front. The formulas will be there. You will be given. Don't worry. You'll be given in paper 2 and in paper 4. Then we'll just come and we'll be able to solve for these ones. So that's going to be way, way, way too easy. Piece of pizza, where are you? Let me check. What paper did I open last time to show you? I'm attracted to this because I can see that there is a piece of pizza in here. But the problem with it is we'll talk about the circle theorems and stuff. Let's quickly find one more question, okay? All we want is one more. Don't worry about circle geometry, okay? We'll talk about it. Anything to do with the circle, don't worry about it. Talk about it. Right now we will want to see this piece of pizza here. Seth, are you still there? Okay, this is the one we just did. Let's go to a different year. Right here. Okay. The problem with this one is it has a cone, okay? Which we don't really want to talk about because it complicates things. I'll come to it if I don't find the one I want. I'll just do it. Which one have we looked at? Summer 22, paper 4-1, March 2022, paper 4-2. One more, okay? These ones, we'll do them tomorrow, these ones. This type. Still from chapter 7. Okay, let me see. Somebody sent me a picture. Okay, so May, June 2020. Or 2023, February, March. Let's see. May, June 2020, question paper 2-2. Let me go to that one. Summer 2020, question paper 2-2. Right. Let's look for a sector in here. There we go. The diagram shows the sector. Find the area. So let me tell you where they are going to get you. They're asking you for things that you cannot find directly. They know you can't find it directly because we know that the area, let's put the three things that we know. We know that area is equal to half r squared theta. So they want area. So we need what? We need to make sure we have r and we need to make sure we have theta. Do we have theta? No, we don't have theta. We want to find this theta. But we also know that s is equal to r theta. So if we have s and we have r, we can find theta. Do we have s? Yep. This is s. Do we have r? Yep. This is r. So can we find theta? Yes. Then can we now then use it in here? Yep. So you're going to first say s is equal to r theta. Okay. So that means you can now say you want theta. So s over r will be equal to theta, which you can write out. Theta is s over r, which is going to be equal to, what is my s? 6.4 centimeters over r. What is my r? 8 centimeters. And of course, you're going to get it in rad. So this is going to be rad. Anyway, what is 6.4 divided by 8? You get 0.8. So it's going to be 0.8 rad. Now, what you're going to do, don't put a pi where there was no pi. It's just 0.8 rad. Okay? The pi would be there if it was already there. So this is just theta. Now, what you're going to do now, you are going to then say area is equal to half r squared theta, which is going to be half. What is our r? We have the r 8. So 8. So half 8 squared by theta, 0.8. Right? So it's going to be equal to 8 squared. So you're going to say 8 squared. You get 64. You say times 0.8. You get an answer. Then you say divided by 2 because it's half of that. So you're going to get 25.6. And it should be centimeters squared because everything is centimeters. So you just come and you say 25.6 centimeters squared. That's going to be how you're going to find it. And this is an example for sector. Thank you for the sector. Let's put another sector, okay? I will go to, it's there in the specimen paper, but I'll give it to you as a question to try. Do I want to do one more? Let me do one more. I'll do 2020 October, November. October, November. Paper 2-1. So here, when we do it tomorrow, I'll show you there are two shapes in here that you mustn't join. Because you can see that this is a sphere, the other one is a cylinder. We'll talk about it tomorrow. So you understand how to do this simple topic. We won't let them fool us. We are past that level. Let me see paper 2-2. There we go. Piece of pizza. We found you. Piece of pizza. This is definitely a sector, right? Because it's a piece of pizza. Can you all see this? Can you all see this? This is going to be the R. This is going to be the theta. Area of the sector. So anyway, you first say theta is going to be 60. They want the area, so we know that area is half r squared theta. But theta should be in rad. So we don't have it in rad. So we'll say 60 degrees over 180 degrees times pi rad. That's how we do it. So it's going to be 1 over 3 pi rad, which you can just say, when you have a 1 on top, you can put pi there. So it'll be pi over 3 rad. All right, this is going to be theta. So you can now say area is equal to half r squared theta, which is half, what is my r? 7.5 squared by theta. What is the theta? Pi over 3. So you're going to do it. So you're going to say 7.5. Let's put it. 7.5 squared, you get an answer. You say times pi, you get an answer. You say divided by 3, you get an answer. You say divided by 2 again because it's half, right? It's half of that. So you're going to get 29.45. This is centimeters squared. This is going to be the area. Okay, and they're likely to put things, let's go to the top and let's see how many decimal places they will tell you here. Answers that are not put to 3 significant figures, non-exact. So to 3 significant figures, it will be 29.5. So area is equal to 29.5 centimeters squared. So this is going to be 29.5 centimeters squared. You have your final solution. Do you understand? Okay, I'll call it. So, do you understand now? This is going to be all you need to know for these sectors. Of course, some will be harder than others, but you'll be fine. Trust me, you will be fine. So I'm just going to give you a bunch of questions for you to try out. Then you give me my solutions. I'm going to put it in the group just now. Okay? I'll put it in the group chat just now. You do, please send, and then I'm going to obviously record in the database. And we'll see how you're doing. Thank you. This is going to be for this small. Should I do that one? I'll do that one tomorrow, the one where there is a cone next to it, okay? After I teach you about these cones and these other shapes and how we're going to deal with it. Because there's a cone next to it, so I'll teach you how you're going to do it. Just to read, there will be a sentence which will link them both. Either they'll say the volume of the cone is this, or they say they open it and then it becomes like that. Whatever they'll say.